Okay, so this is the 2023 Ordinary Level Maths Paper 1. This is question 1. The prices of houses in a particular area have been increased over a number of years. A house is valued at 240,000 at the start of 2019. By the start of 2020, a year later, the price of the house has increased by 8%. And then by the start of 2021, the price of the house has increased by a further 9% based on the 2020 price. Work out the price of the house at the start of 2020 and the start of 2021. Okay, so what we're going to do here is first look at 2019 to 2020. So at the start of 2019, it was valued at 240,000 euros. Now we want to increase that by 8%. So a couple of ways you can do this. You can get 8% of this and add it on, but a quicker way is just to multiply by 1, which won't change it, but then add on the 8%, which is 0.08. So if you multiply by 1.08, that will increase this by 8%. So when you do that, you get 259,200 euros. So you start again, then you take the 259,200 euros, and this time you want to increase that by 9%. So you multiply by 1.09 this time. So we're going to increase it by 1.09. When you do that, you get 282,528 euros. So our answer is price at the start of 2020 is 259,200 euros, and then at the start of 2021 the cost is 282,528. And that's it for part A. So let's have a look at part B. Another house was valued at 460,000 euros. 1 year later, the value of the house had gone up to 472,000 euros. Work out the percentage increase in the value of the house over the year. Give your answer to one decimal place. Okay, so the first thing we need to do here is find the increase. The increase in value is going to be equal to the higher value, 472,000, subtract the original value, 460,000, and that will give you 12,000 euros. So it went up by 12,000 euros. You now want the percentage increase. So the percentage increase is the increase, which is 12,000 euros, divided by the original value, which is 460,000 euros. Then just multiply by 100, and we want this to one decimal place, so that's 2.6%. That's it for part B. Part C, the third house was valued at 265,000 euros. Over the following 4 years, the value of the house increased by % each year compared to the previous year. After 4 years, the house was valued at 370,000 euros. Work out the value of or, setting F is equal to 370,000, P is equal to 265,000, and T is 4 years into this equation here. Give your answer to one decimal place. So we've got F is equal to P times 1 plus or over 100 to the power of T. Now we're told here that F is 370,000. That's going to be equal to 265,000. Multiply that by 1 plus or, we've got to find, and T is 4. So you've got to manipulate this equation to try and get or on its own. So the first thing you're going to do here is just get rid of this thing here. So you're just going to get rid of that 265,000. So let's do that first. So that's multiplied by the bracket here, so you've got to divide. Now when you divide this number here by this number here, you get 74 over 53. And that's equal to 1 plus or over 100 to the power of 4. Okay, so the next thing we're going to do then is get rid of this 4 up here. Now this entire bracket here is raised to the power of 4, so the opposite to raising something to the power of 4 is to get the fourth root of the right hand side and the left hand side. So in other words, if you square something, the opposite to squaring would be to square root it. So we're going to get the fourth root. So basically what we're going to do is this, the fourth root of the left-hand side. And the fourth root of the right-hand side will just cancel that 4 there. So you'll have 1 plus or over 100. Now you can do this on your calculators. It's just a case of, let me just show you where the button is here. So you can type in Shift and this button here, and that allows you to put in the 4 there, and in here then you can put a fraction, which is 74 over 53. If you press equals, you get that big long number there. You don't need all those decimal places, but let's just write a few of them down anyway. 1.087023 and so on. And that's equal to 1 plus or over 100. Next thing you got to do is subtract 1 from the right hand side and the left hand side. That gives us 0.087023. So that's our or over 100. And then finally we want to get rid of that 100, so that's dividing. So the opposite to dividing is multiply. So you've got to multiply both sides by 100. We want one decimal place, so I'm just going to go 8.7. So that's my answer there, 8.7%. Okay, so that's question 1 done. Let's have a look at question 2. This is a complex number question. So the complex number Z1 is shown in the Argand diagram. So this is Z1 down here. Plot and label Z conjugate, the complex conjugate of Z1 on the diagram above. Well, the complex conjugate, this is 3 minus 3i, so the complex conjugate is 3 plus 3i, so that would be just up here. So this is Z1 conjugate, which is 3 plus 3i. Okay, so that's part 1. Let's have a look at part 2. Plot and label Z2 and Z3. We're given Z2 and Z3 here. So Z2 is 5 plus I, so 5 plus 1i is going to be here. So that's Z2. Z3 is 6 minus 2i, so there's 6, go down 2, 6 minus 2i, so that's Z3. I think that's all we had to do there. Plot and label Z2 and Z3 on the diagram above. Okay. Write 4z minus 5z3 in the form a plus bi. Okay, so we've got to do 4 and then times z2. So z2 is 5 plus I. And then we've got to do minus 5 times z3. Well, z3 is 6 minus 2i. Okay, so we got to multiply this out. So it's 4 5's 20 plus 4i minus 30. Then minus minus is plus, 2 5's 10. So that'll give me, you can add the real parts, you can add the imaginary parts. So the real parts are 20 and minus 30. That's minus 10. The imaginary parts are 4i and 10i. That should be a 10i there. So 4i plus 10i is 14i. And that's it for part 3. Is there another part? Yes. Find the value of Z3. And these two lines just mean the modulus of Z3. So remember, Z3 is 6 minus 2i. So our Z3 is 6 minus 2i. We've got to find a modulus. The modulus is the square root of a squared plus b squared. The 6 is the a plus b squared. Then the b is the minus 2. Just put in the minus 2 there as well. You've got to square that, square that. That gives us the square root of 6 squared, which is 36, minus 2 squared is plus 4. So that's the square root of 40, which is 2 root 10. You can just type that into your calculator, press equals, you get 2 root 10. It says give your answer in third form anyway. So that's it. That's part 4 done and part A done. So let's have a look at B then. The complex numbers Z4, 5, 6, and 7 are shown in the Argand diagram below. The diagram is to scale. Tick the box to indicate which of Z4, 5, 6, or 7 has the largest modulus. Give a reason for your answer. Well, if you look at the modulus, really is the distance that the complex number is from the origin. from this point here where the two axes, the real and the imaginary axis, cross. So from this point here, 0 plus 0i. So this point here. So if you look at all of these complex numbers, you'll see that Z5 is furthest from the origin. So Z5 is going to have the largest modulus. So we're going to tick Z5, and the reason is Z5 is furthest from 0 plus 0i, or the origin if you like. And that's it really. Let's have a look at question 3. Solve the following equation. So we have 3 times 2x plus 4 minus 5 is equal to 3. Okay, so let's work through this. Multiply out the brackets first maybe. 3 2 6x plus 3 4 is 12 minus 5 is equal to 3. 6x plus 12 minus 5 is 7 is equal to 3. That gives 6x is equal to, subtract 7 from both sides. That gives minus 4. And finally then divide by 6. That's minus 4 over 6, which is equal to minus 2 over 3. And that's really it for A. Okay, so in part B here we have to graph each of the following inequalities on a number line. Note that x comes from a different set of numbers in each case. Okay, so let's have a look at part 1. X is less than or equal to 2.8 and x is real. So 2.8 is going to be somewhere around here. So we draw a circle there and it can be equal to 2.8, so I'm going to fill that in. Now it has to be less than or equal to, so what you do is you draw a kind of a line down along here, all the way down along there like that. Put a little arrow there to show that it goes on forever. You can imagine that or here stands for river, so we're drawing a little river if you like. Okay, so let's have a look at the second one then. X is less than or equal to 2.8, but this time x is an integer. So again, 2.8 is here. But 2.8 is not an integer. 2.8 is a real number, but not an integer. So let's go to the next number less than 2.8. That is an integer, and that is 2. Then the next one is 1. 0 is an integer. 1 is an integer. Minus 1, I should say. Minus 2, minus 3, minus 4, and we're going on forever down along that way. Okay, so that's integers. So let's have a look at the next one. Same thing again, but this time x is a natural number. So less than 2.8. So 2.8 is around here. The next natural number less than 2.8 is 2. The next natural number less than this is 1. And that's where we stop. 0 is not a natural number in our course anyway. So that's really it. That's that one done. Let's have a look at part C. So in part C, use algebra to solve the following simultaneous equations. X minus y plus 1 is equal to 0 and 2x plus 4y is equal to 19. Okay, so I'm going to just write those out. X minus y, I'm going to bring that 1 over to the other side, so it's minus 1. Second equation, 2x plus 4y is equal to 19. This is equation 1, this is equation 2. I'm going to take equation 1 and multiply it by 4 to try and get rid of this y. So if I multiply equation 1 by 4, I get 4x minus 4y is equal to minus 4. So just put a line underneath, you can add these two equations now. So 4x plus 2x will give me 6x. The y's will cancel, that's what I wanted to happen, or you'll get 0 if you add them. So 19 minus 4 is 15. So that just means 6x is equal to 15. Divide by 6 to get rid of the 6, that's 15 over 6. So we want to divide the top and the bottom by 3. 3 into 15 is 5. 3 into 6, 2. So we have our x value now. We've just got to work out the y value. So take one of the equations. I'm going to take x minus y is equal to minus 1. That's equation 1. Substitute in 5 over 2 for x. 5 over 2 minus y is equal to minus 1. So next thing you've got to do is bring the 5 over 2 over to the other side. That gives minus y is equal to minus 1 minus 5 over 2. Well, 5 over 2 is just 2.5, so that will just give us minus 3.5 on this side, which is just minus 7 over 2. So if minus y is equal to minus 7 over 2, that gives y then is equal to plus 7 over 2. So my answer then is the x is 5 over 2 and the y is 7 over 2. So in other words, these two lines here, these are two straight lines, and the point of intersection is actually what we found, and that's our 5 over 2 and 7 over 2. Okay, so that's it for question 3. Okay, so let's have a look at the next question, which is question 4. The graph of the function g is shown on the coordinate diagram below for x between minus 3 and 2. X is real. Use the graph to answer parts A 1 to 4. Estimate the value of g 1.5. So g 1.5, that means x is 1.5. So we need to go out to here, then up along here and across. Now it says use the graph. Usually when it says that, it means that they want to see these lines going up and across. So you can use a ruler to do this. So what you can do is just draw a line up along here like this, and then across here like this. So the answer here is just 2. So my first answer here is 2. Okay, so the second one then says, let's see, estimate the value of x this time for which g of x is equal to minus 6. That means y is equal to minus 6. And again, it says show your work on the graph. So they need to see these dotted lines. Obviously use a ruler here. I'm just doing it freehand, so it doesn't look very straight, but you guys should be using a ruler. So estimate the value of x, which g of x is minus 6. So g of x is minus 6. So if g of x is minus 6, we're going to start from down here. Y is minus 6. And then we're going to come up along here like this. So that's my answer there. So if y is minus 6, I'm going to say x is minus 2.75. Tick one box to show how many real roots the function g of x has in this domain. Give a reason for your answer. Well, we can see here that the graph cuts the x-axis only in one place. That means it only has one real root, and that root is here at about 1.25. So we're going to say that it has one real root. The reason the graph cuts the x-axis only once. That's it. That's that part. From the graph, estimate the coordinates of the local maximum point and the local minimum point of g of x as accurately as possible. So the local maximum, the local minimum. Well, this is the local maximum here. This is the local minimum down here. So let's see, where are we? I'm going to go from here. It's a little bit to the left of that line, so I might just come up along here. That'll give me my x value. And here I'm going to look at about there for my x value. So the local maximum then is going to have an x value of minus 1.6, I'm going to say. And the y value then is going to be here at minus 1. The local minimum then is here, so I'm going to say an x value of 0.25 and a y value of about minus 3.25. So 0.25 minus 3.25. So 0.25 and minus 3.25. Now there will be a tolerance allowed for this because you're reading from a graph here. They will allow a certain tolerance around these values. So I wouldn't worry if you didn't get exactly these answers. Let's have a look at B. A different function h of x has the following equation. H of x equal x Cubed plus 2x squared minus x minus 8. Find h prime x, the derivative of h of x. So all we've got to do is derive that function. So it's going to be bring down to 3x, reduce the power by 1 to 2. Bring down the 2, multiply by 2 gives 4, reduce the power by 1. There's a 1 here over the x, so that's x to the power of 1. So bring the 1 down. Reduce the power by 1 will give x to the power of 0. X to the power of 0 is just 1. So all we end up with there is minus 1. So it's 3x squared plus 4x minus 1. Part 2 then, find the equation of the tangent to h of x at the point 2, 6. The tangent. Now a tangent is just a straight line. The equation of a tangent therefore is y minus y1 is equal to m into x minus x1. Now this formula is in your tables. Two things you need to put into this formula. You need a slope and you need a point. Well, we're given a point 2, 6. So that's our x1, y1. This is our x1, this is our y1 here. We've got to work out the slope. Now to work out the slope, what you would do is look at what we got in the previous answer. We got 3x squared plus 4x minus 1. This gives us the slope of any tangent to the curve at any point x. But we know what the x is. We know that the x is 2. So we can just put 2 into this. So we get 3 times 2 squared plus 4 times 2 minus 1. When you do that, you get 2 2s are 4, 3 4s 12, plus 8 minus 1. That's 20 minus 1, which is 19. So that means the slope of our tangent at the point 2, 6 is 19. So our equation then is y minus y1, which is 6, is equal to m, which is 19, x minus x1, which we have as 2. So you need to multiply that out then. So it's y minus 6 is equal to 19x minus 38. Now normally the way I write the equation, you can write the equation a couple of ways, but normally the way I do it is write it in the form ax plus by plus c equal to 0. So in other words, I'm going to leave the 0 here, 19x there, bring over the y, it's going to become minus y, and then I'll have minus 38 plus 6, minus 38 plus 6 is minus 32. So this would be my answer here. You could probably put it in the form y is equal to mx plus c either. It doesn't actually say what way they want the answer, but this is the way I would normally write it. Okay, so that's that question done, I think. Yeah, let's move on to question 5. A company is repairing a railway line. As part of this work, it is laying new railway tracks. It costs €12,000 to lay 240 metres of railway track. Work out how much it would cost to lay 320 metres of railway track. So we have 12,000 for 240 metres of railway track. We want to work out how much it will cost. So put what it will cost on the right hand side. So it's 240 metres. That's equivalent to €12,000. So the first thing you would do is work out how much it would cost for 1 metre. So that's going to be equal to 12,000 divided by 240. Now we want to know how much it would cost to lay 320 metres. So 320 metres, you just take the 12,000 over the 240 and multiply by 320. In other words, how do you get from there to there? Well, you would divide by 240. How do you get from there to there? Multiply by 320. You do exactly the same on the other side. So when you do that, you get €16,000. And that looks about right. If it costs €12,000 to lay 240 metres, to lay 320 is going to cost more. 16,000 looks roughly right anyway to me. It would take 6 people 8 days to replace a track on a different part of the railway line. Work out how long it would take 4 people to replace these tracks, each working at the same speed. So we want to work out how long it would take. So you have 6 people. And again, that's equivalent to 8 days to lay these tracks. So one person then is going to be equal to. Now in the previous question what we would have done is divided by 6. But if you think about it, if you have 6 people and it takes them 8 days to do a job, one person is going to take longer. So it's actually a times 6 in this case, that many days. Now we want 4 people then, 4 people. So if it takes one person 48 days, 4 people is going to take less. So it's going to be 8 times 6 divided by 4. And in this case it's going to be 6 8's 48 divided by 4, so that's 12 days. And again that seems to be right. If it takes 6 people 8 days, 4 people then 12 days, sounds about right. It's going to take more than 8 days, so it's going to take about 12. It's going to take 12 days. Okay, let's have a look at B. Two towns A and B are 120 kilometers apart. So you got town A, you've got town B, and they are 120 kilometers apart. A train travels from A to B at an average speed of 180 kilometers per hour. Work out the time it takes to get from A to B. Give your answer in hours as a fraction. This is just a speed, distance, time question. And if you remember, I don't know if some of you use this triangle here, Dad's silly triangle. You got speed is distance over time. So this is just called Dad's silly triangle. So you have speed is distance over time. Distance is speed times time. Time is distance over speed. So we want time. So it says work out the time it takes. So time is distance over speed. So we want time is distance over speed. In our case, the distance is 120 kilometers. The speed is 180. So if you do that, you get 2/3 of an hour. It says give your answer as a fraction, so that's it. On the way back from B to A, so now we're going backwards. So we have B to A here. We're going this way. The train travels at an average speed of 220 kilometers per hour. And again, it's still 120 kilometers. Work out the average speed of the train for the entire journey while it is traveling from A to B and back again. Give your answer in kilometers per hour. They give you a hint here. It says first work out the time it takes for the entire journey. Well, we have the time it takes to get from A to B. We've got to work out the time it takes to get from B to A. So it's the same kind of thing again. Time is distance over speed. So in this case, the distance is 120. The speed is 220. So the time on the way back is going to be 6 over 11 hours. Now we've got to work out the average speed of the train for the entire journey. So we need the overall time and we need the overall distance. So we have the overall distance, we just need the overall time. So the total time is just going to be 2/3 of an hour plus 6/11 of an hour. So if you add those, you get 40 over 33 of an hour. So we have the overall time now, so all we've got to do now is work out the speed. So speed is distance over time. So the distance is 240 kilometers. Out is 120, back is 120, so 240 in total. The time is 40 over 33. So you can just type all that into your calculator, 240 divided by this fraction here, and that gives you 198 kilometers per hour. That's the overall average speed for the entire journey. Okay, so let's move on to question 6 then. G of x is the following function, x squared plus 8x minus 6. Find the value of g minus 5. So all you got to do is put minus 5 in there. So minus 5 squared plus 8 times minus 5 minus 6. So 5 5's 25, minus times minus is plus, 5 8's 40, plus times minus is minus, and minus 6 as well. That gives a total value of minus 21. Okay, use calculus to find the value of x, which gives a minimum value for g of x. So this function up here is a quadratic. It looks like this. So there is a minimum value down here, and we've got to find the minimum value for x. This point down here has an x and a y value. We're just asked to find the value of x. So when you differentiate a function, it gives you the slopes of tangents. So there are loads of tangents to this curve, but there's one down here at the bottom, right down at the minimum value, and that has a slope of 0. So when you differentiate the function g of x is equal to x squared plus 8x minus 6. Differentiated, you get a g dash x, g prime x, gives you 2x plus 8. This gives you the slope of any of these tangents at any point x. So what we want is the slope that is 0. So in other words, we want 2x plus 8 to be 0. This will give us our x value. So let's do that. So we've got 2x plus 8 is equal to 0. So 2x is equal to minus 8. That gives us an x value of minus 4. So that just means that back up here, this x value here is minus 4. If we were asked to find the y value, we just put that minus 4 back into the original equation, and that'll give us our y value. Okay, so we weren't asked for that. We were just asked for the x value. Expand and simplify. So we have 2x minus 4 squared, which means 2x minus 4 times 2x minus 4 minus 6. Now really what you've got to do here is take the 2x in the first bracket, so you've got to take this 2x, multiply it by these two here, take the minus 4, multiply it by these two here, and then do the minus 6 at the end. So it's going to be 2x times 2x, which is 4x squared, 2x times minus 4, which is minus 8x, minus 4 times 2x, which is minus 8x, and then minus 4 times minus 4 is plus 16. And that's a minus 6 out at the end. So that's going to give us 4x squared. There are no other x squareds. There's a minus 8x, a minus 8x, that's minus 16x. And then we've got plus 16 minus 6, which is plus 10. So I think that's it. 4x squared minus 16x plus 10. Okay, there's another part to this. Part C, solve the following equation. This is a quadratic equation. Give your answer to 2 decimal places. So that should indicate to you that we probably will need to use the quadratic formula, the minus b formula. So it's a good idea to write down what a is. A is 9, and b is 6, c is minus 5. Write the formula down. It's in your tables. It's minus b plus or minus the square root of b squared minus 4ac all over 2a. Now just stick in the values. So minus b, so b is 6, so it's going to be minus 6. Plus or minus the square root of, put these in brackets, it's going to be 6 rather than minus 6 here, so that should be 6 here, which we've got a square, and then it's minus 4 times a, which is 9, c, which is minus 5. All of that is over twice 9. So it's minus 6 plus or minus the square root of something over 18. Now 6 squared, 6 is 36. Here you've got a minus times a plus times a minus. Minus times plus times minus. Minus times plus is minus, and then minus times minus is plus. So your answer here should be plus 4 times 5, which is 20, and then 9 times 20, which is 180. Now we've got minus 6 plus the square root of 180 plus 36 is 216 over 18. Or we've got minus 6 minus the square root of 216 over 18. So these are our two answers. Now we were required to give our answers correct at 2 decimal places. So when you do each one of these individually, you can do them on your calculator. The first one here on the left will, to 2 decimal places, is 0.48. This one over here is minus 1.15. Okay, let's move on to question 7, first long question. So when it rains on land, some of the rain soaks into the land and the rest runs off the land. The runoff curve number C is a number used when estimating the amount of rain that runs off a particular area of land. C is given by C is equal to 1000 over S plus 10. Now S is the measure of the maximum amount of rain that can soak into the soil. Find the value of C when S is equal to 15. Okay, so straightforward enough here, I think. So we have C is equal to 1000 over the S here now is going to be 15, so it's 15 plus 10. So it's 1000 divided by 25, and that's just 40. Okay, second part. When S increases, does C increase or decrease? Justify your answer using the equation C is equal to 1000 over S plus 10. So it's going to decrease. And the reason for that is, as the denominator of any particular fraction increases, the fraction itself will decrease. Now it says use the equation C is equal to 1000 over S plus 10 to justify your answer. Let's take S is equal to, we've already done S equal to 15, so let's take S is equal to, let's say 25. That gives C is equal to 1000 over 25 plus 10. So that would just give us 28.6. Also, let's say S is equal to 35. That'll give us C is equal to 1000 over 35 plus 10. And again, that's going to decrease further to 22.2. So we've gone from S equal to 15, 25, and 35. And we can see that C has decreased from 40 to 28.6 to 22.2. I think that's enough of a justification there, really. Rearrange the equation to write S in terms of C. Okay, so we have C is equal to 1000 over S plus 10. So the first thing you would do, we have a fraction equal to a fraction, so cross multiply here. So that would give us C times S plus 10 is equal to 1000 times 1. You can multiply this out, you get CS plus 10 times C is equal to 1000. We don't need the 10C, so we want to get the S on its own. So leave the CS on this side, so you've got 1000 minus 10C. And then I'll just come up here. That will finally give me S on its own here is equal to 1000 minus 10C all over C. Or another way of writing that would be 1000 over C minus 10C over C, which is just 10. So two different ways of writing the same thing. Okay, so that's part 3 done. The value of C goes from 30 to 100. Use your answer from part A3 or otherwise to find the range of values of S. So if we take C equal to 30, that'll give us an S value equal to 1000 minus 10 times 30 over 30. And when you work that out, you get 70 over 3. Let's take C is equal to 100. That gives us S is equal to 1000 minus 10 times 100, which is 1000. So we'll get 0 on the top. So that means we're going to end up with 0. 0 on top of a fraction will just give you 0. So what does it say? Find the range. So it goes from 70 over 3 to 0. Okay, next one. Over the course of one day, 24 hours, the probability that it is raining in Waterville, P of t, could be modeled by the following function. P of t is equal to 0.3 plus 0.02 times t. Here, probability of t is the probability that it is raining t hours after the start of the day, and the day goes from 0 times 0 up to time 24 hours. Write down the probability that it is raining at the start and the end of the day. That is, find the values of P0 and P24. So P0 is just going to be equal to 0.3 plus 0.02 times 0. If you work that out, this will just become 0 and you're just left with 0.3. The probability then at hour 24 is going to be 0.3 plus 0.02 times 24. And when you work that out, you get 0.78. So the probability at the beginning of the day that it's raining is 0.3, and the probability at the end of the day is 0.78. So the probability that it is raining by the end of the day has substantially increased. So part 2 then just says find the value of p prime t, the derivative of t, and explain what the value of p prime t means in this context. So our function is p of t is equal to 0.3 plus 0.02 t. We want p prime t, the derivative of this function here. So the constant, if you do a derivative of 0.3, you'll get 0 because it's a constant. Here, there's a 1 up here, so bring the 1 down, multiply it by the 0.02. Subtract 1 from the 1 up here, that gives you 0. T to the power of 0 is 1. So you get 1 times 0.02. In other words, our answer is just 0.02. So what does it mean then? So it's the rate of change. The rate of change, or the increase, the rate of increase in this case, because this is positive, of the probability per hour that it is raining is constant at 0.02 per hour. I've kind of said that already over here. That's it. Probably a tricky question, but that would generally be the explanation there. Okay, at a certain time, the probability that it is raining according to this model is 0.35. Work out the probability that it is raining exactly 1 hour later according to this model. Okay, a couple of ways of doing this. The original equation was P of t is equal to 0.3 plus 0.02t. Now we know that our probability here is 0.35. So let's work out what time that is happening at. So let's just bring over the 0.3, that gives us 0.05 here. And then divide by 0.02. If you divide by 0.02 here, you get 2.5. So that just means 2.5 hours after the start of the day, the probability that it is raining is 0.35. So 1 hour later, we need the probability of it raining at 3.5 hours after the start of the day. So that's going to be 0.3 plus 0.02 times 3.5. So when you do that, you get 0.37. Now the other way of doing this is just to look at what we did in the previous question. We know that the rate of change of the probability is 0.02 per hour. So in other words, if the probability at the moment of it raining is 0.35, 1 hour later, the probability is going to have increased by 0.02. So that also gives us 0.37. Okay, so let's look at question 8. So a rectangular garden 50 by 30 meters contains an irregular shaped pond of length 18 meters as shown in the diagram below, not to scale. Find the area of the whole garden, that is the total area of the rectangle. Okay, so that's about as easy as you're going to get. The length is 50, the width is 30, so the area is equal to 50 times 30, which is just 1500 meters squared. The width of the pond is measured at intervals of 3 meters starting at the right hand edge of the pond. These measurements are given on the diagram correct to the nearest meter. Use the trapezoidal rule and the measurements in the diagram above to work out an estimate for the area of the pond. Okay, so the trapezoidal rule is just, it gives you the area of irregular shape. So we're going to say the area is going to be, well, it gives you an approximation. It doesn't give you the exact area. So the trapezoidal rule is going to give you an approximate area for irregular shapes. So the area is going to be equal to h over 2 times the first plus the last plus twice the sum of the rest, if you like. I'll explain what all that means in a second. So h is really just going to be these regular intervals here, these 3 meters across here. So there's 3 meters, 3 meters, 3, 3, 3, and 3. So that's our h. So it's going to be 3 over 2. So what do we mean by the first? The first is the first height here. And the first height here is going to be 0. So we're going to put in a 0 there. The last height we can see here is 2 meters. That's this height here at the end, 2 meters. So that's going to go here. And then it's twice the rest of them added up. So we got to add up 10, 14, 12, 10, and 8. So that all adds up to 54. So we're going to put 54 here. And then when you do all of that, you get 165 meters squared. So let's have a look at part C. Suggest a way in which the trapezoidal rule could be used with different measurements to get a potentially more accurate estimate of the area of the pond. So you can see here that the pond is being divided up into 3 meter intervals. So it gives an approximation. What we're effectively doing is getting the area of trapeziums along here and adding them up. But it's only an estimate. So if we reduced this from 3 to 2 meters, for example, so there were more intervals, or even to 1 meter or half a meter or so on, the more intervals we have, the more accurate our area is going to be. So what I would say is something like decrease h. So that would just mean increase the number of intervals that the pond is divided into. H is equal to 2 or H is equal to 1. So you just decrease this H. Apart from the pond, the rest of the rectangular garden is covered in grass. The actual area of the pond is 172 meters squared, so we weren't too far off at 165. All of the grass in the garden needs to be resown. The cost is $2.55 per square meter that needs to be resown. Work out the cost of resowing the grass. Okay, give your answer correct to the nearest 10 euros. So this area around here is what we're talking about. You obviously can't sow grass in here, that's the pond. So we need to take the whole area, subtract the area of the pond, and that gives us the area that we're going to sow. So we're going to take 1,500 meters. We're going to subtract the 172 meters. That gives us 1,328 square meters of grass that can be sown. We know that 1,328 needs to be multiplied by the cost per meter, which is 2.55 euros for every square meter. So that comes to 3,386.40, and we need to round that down to the nearest 10 euros. So that's going to be 3,386 is close to 90, and that's it really. 0.00 there if you like. Okay, so that's part D. Let's have a look at part E. Some materials were imported from England by the gardener for resowing the grass. The cost of materials is £840 sterling. This includes an import duty of 16.9%. Work out the cost of the materials before the import duty was added. Give your answer correct to the nearest penny, that is the 2 decimal places. Okay, so we want to find the cost. So we know that 16.9% is included in the 840. That means that 840 can be represented by 116.9%. It's 116.9%. We want to go down to 1% and then back up to 100%. The 100% will represent the cost before the import duty was added up. This is before the 16.9%. So this 116.9 is equivalent to the 840 pounds. So we want to go down to 1, so divide 840 divided by 116.9. In other words, what do you do to that to give you 1? If you divide 116.9 by 116.9, you'll get 1. So do the same over here. Divide by 116.9. Now how do you go from 1 up to 100? Well, you just multiply by 100. 1 times 100 gives you 100, so you do exactly the same here. Multiply by 100. So you take your 840 over 116.9, multiply by 100, and that should give you 718.56. That's in pounds. So that would be the cost in pounds before the import duty was added on. And it said give your answer correct to the nearest penny, so to 2 decimal places, that's what we've done. Okay, so let's have a look at the next one then. The gardener paid 840 pounds. Paid the 840 pounds in euros. Okay, so the exchange rate was €1 is 0.8547 pounds. He also paid a fee of 2.5% of the 840 pounds as commission. Work out how much he paid in total in euros, correct to the nearest cent. Okay, so he paid 840 pounds sterling and he paid that in euros, but there was commission. So what we need to do is see how much he actually paid. So there was 2.5% commission on the 840, so we need to multiply that by 1.025 to add on the commission. So that comes to 861 pounds sterling. This is what he actually paid here. Okay, so what we want to do then is just work out how much he paid in euros. So again, we're going to look at this exchange rate. We want euros, so we're going to put euros on the right hand side. So I'm going to take 0.8547, this is pounds sterling, and that's equal to €1. So put what you're looking for on the right hand side. Go down to £1 and then go up to 861 pounds here. So same thing again. How do you go from 0.8547 down to 1? Well, you divide by 0.8547. How do you go from 1 up to 861? You multiply by 861. So it's 0.8547 multiplied by 861. And that gives you a total of 1007.37, and that's in euros. That's our answer there. Question 9. So the diagram below shows the actual daily number of new cases of a disease from day t is equal to 0 to day t is equal to 25. It also shows the number of cases according to a mathematical model over this period of time. So we have here the actual number of cases, and then we have the model for the number of cases. So the dots are the number of cases, and the line is the model for the number of cases. So the question is, from the diagram, estimate the number of actual new cases there were on day t is equal to 12 using the relevant dot. So t is equal to 12 is going to be here. This is t is equal to 10, this is t is equal to 11, this is t is equal to 12. So if you come over here, you should end up somewhere around here, which I'm going to say is 1500. So it's the daily number of new cases is 1500 on day 12. So 1500 can go there. Next question. According to the model, that is the curve, there were 1,000 new cases on day t is equal to 12. So this is from the model. The model is saying that there were 1,000 new cases. Work out the percentage error in the model's value for day t is equal to 12. Use your answer to part A1 above as the actual value for day t is equal to 12. Okay, so the actual value was 1500. We want to subtract 1,000 to give us our error, which is 500. So this is our error. To get the percentage error then, you take the 500, put it over the accurate value. Now the accurate value is 1500, so when you do that you will get 33% to the nearest percent, 33%. Okay, so that's part 2. Let's have a look at part 3. Show that it takes approximately 5 days for the daily number of new cases to double according to the model. That is according to the curve in the diagram. So show that it takes. So the way you could probably do that is to do some kind of a table. So if you take the day and the number of new cases. So we take days equal to 0. We need to go up 5, 10, 15, 20, and let's say 25. Let's see what happens to the number of cases according to the model. That's the line. So if we take day 0, which is here, I'm going to say 2, 4, 6, I'm going to say 200 here for day 0. Day 5 then, according to the curve, looks to me about just less than halfway, so I'm going to say 400. Day 10 is here. It looks to me around 800, 850, somewhere around there. Let's say 800. Day 15 should be somewhere around 1600. So, and it does look to be around 1600, just above halfway here. So I'm going to say 1600 for day 15. Day 20 is here. So that should be around 3200 if it was doubled. And it could be 3200, maybe a little bit less, 3100 maybe. I'll say 3100, approximately doubled. And then 25 should be, if it doubles, 6200. There's 6000 there. Looks about 6200, all right. So I'm going to say 6200 here. Now it did say here, show that it takes approximately 5 days for the daily number of new cases to double according to the model. So I mean, we haven't exactly doubled every single time here, but it is an approximation. So it's approximately doubled each 5 days. Now let's have a look at the next one. Hence estimate on what day or value of t the number of new cases will first be at least 100,000 according to the model. Show your working out. Okay, so I'm going to do the same thing again. We're going to take the day and then the number of new cases. So I'm saying on day 25 there were 6,200. So let's keep going. Let's go to 30. So that's going to be 12,400. On day 35, you need to double that. So that's going to be 24,800. On day 40, and we need to double that. That's going to be 49,600. So on day 45, it's going to be 99,200. Now we're just underneath the 100,000 here. So another 5 days is going to bring that up to 198,000. So we're way above what we need to be at that stage. So I'm going to give it one more day here. So I'm going to say my answer here is day 46. Now again here they say estimate on what day. So this is an approximation, and I presume in the marking scheme they're going to allow a tolerance of a day or two around this particular value here. So it doesn't have to be worked out absolutely accurately. Okay, so let's move on to the next question. The daily number of new cases of a different disease can be modeled using the function d of t is equal to 2100 times 1.8 to the power of t, where d is the daily number of new cases and t is the time in days from t is equal to 0 to t is equal to 14. So let's see, we've got to fill in the table below to show the value of d of t for the given value of t, give each value correct to the nearest whole number. Okay, so I filled out these numbers here. It's just really a case, if I do one example here, it's just a case really of putting in the t into the formula. So if we want, for example, day 4, we would do d of 4. That's 2/100 times 1.18 to the power of 4, and that'll give you 4071, which is what I got here. Okay, so that's it. The next part, let's see, we have to draw the graph using those numbers from 0 to 6. So let's do that. 0 is 2/100. So 2/100 is going to be somewhere around there. The next one is 2478. So 2478 is going to be somewhere around here. Number 3, 2924 for day 2, 2924 is going to be somewhere around there. 3450 for 3, 3450. 3450 is going to be there somewhere. 4071. So 4071 will be somewhere around there. 4804 is next, so 4804 will be around here. And the last one, 5669. 5669 will be somewhere around here. So you just got to connect those up then. It's going to be some kind of a curve anyway. It's not a straight line. And that's it. Draw the graph of y is equal to d of t. That's it. Next question. Measures are put in place to slow down the speed of the disease from t is equal to 14 days onwards. The number of new daily cases start to decrease. For t greater than or equal to 14, the number of new cases on each day t can be modeled by a times 0.83 to the power of t. On t is equal to 14 days, there were 21,309 cases according to this model. Use this to work out the value of a. Okay, so our formula is k of t is equal to a times 0.83 to the power of t. So k of t then is going to be 21,309. We want to work out what a is when t is 14. We've got to put 14 there instead of t. So to work out a then, you just divide. You take 21309. Divide that by 0.83 to the power of 14. You can do that on your calculator and you get 28938 0.8 and so on. Now it says give your answer in the form b by 10 to the power of n, in other words scientific notation. So if we do that, we'll get a is equal to 2.8. It says to 2 decimal places, so it's going to be 2.89 by 10 to the power of. So what I've done is I've taken the decimal point here. I've taken this decimal point and I've brought it back to here to make a number between 1 and 10. We've now got to use this part here to bring it back to where it was. So we've got to bring it back to this place here again. So you got to bring it to the right 1, 2, 3, 4, 5 places. So you multiply by 10 to the power of 5. And that's it for question 9. Okay, so let's move on and have a look at question 10. Find the volume of a cylinder with a diameter of 18 millimeters and height 5 millimeters. Give your answer correct to the nearest millimeter cubed. So the volume of a cylinder is pi r squared h. So we want pi times the radius, which is 9, which you need to square, and the height is 5. When you do that, you get 1272 millimeters cubed. A metal ring could be made by removing a cylinder of diameter 14 millimeters and height 5 millimeters from the cylinder in part A1. Work out the volume of metal in the ring correct to the nearest millimeter cubed. So we've got to take 1272. You've got to subtract pi r squared h. That's the metal that's going to be removed from the center here. It's a cylinder in the middle. So that's going to be pi, which is just pi, times the radius, which is 7, which we've got a square, and then the height, which is 5. So when you do all that, you get 502 millimeters squared. Now, if you took the previous answer as 1272 and did it, you'll get 502. If you take the non-rounded decimal that you got in part 1, you'll get 503. I'm not sure which answer the marking scheme will require you to do, but that's the procedure anyway, at least. Let's have a look at the next question. B. Many gold rings are made of a mixture of pure gold and other metals. One particular ring weighs 8 grams. It contains 3 grams of pure gold. Work out the percentage of the weight of this ring that is pure gold. Well, it's just really 3 as a percentage of 8. The 3 grams of gold represent 3/8 of the weight of the ring. So to convert that into a percentage, you just multiply by 100. So that's just going to be 37.5%, and that's it. Pink gold is made up of pure gold, copper, and silver. The ratio of pure gold, copper, and silver is 15. 15 is to 4 is to 1 respectively. So this is the gold, this is the copper, and this is the silver here. Now if you add those 3, you'll get 15 and 4 plus 1 is 20. So we're going to use that. Work out the number of grams of pure gold in a pink gold ring that weighs 25 grams. So we're only interested in the gold here. So the gold is going to be 15/20ths of the entire ring. We've got to multiply that by the weight of the ring, which is 25 grams. Multiply that out and you get 18.75 grams. So there are 18.75 grams of pure gold in the pink gold ring. Rose gold is made up of 75% pure gold, 22.25% copper, and 2.75% silver. Express the ratio of pure gold, copper, and silver in rose gold in the ratio ABC. In its simplest form, where A, B, C have to be natural numbers. Okay, so we have 75 is to 22.25 is to 2.75. There's our ratio. Now, if you think about that, this is 75, this is 22 1/4, and this here is 2 3/4. So we've got this is over 1 if you like, this is over 4, and the last one is over 4 as well. So I'm just simply going to multiply everything by 4. So if I multiply 75 by 4, I'll get 300. Multiply 22 1/4 by 4, I'll get 89. Multiply 2 3/4 by 4, I'll get 11. Now there is no other way of simplifying that as far as I can see, so that is our answer. We have A, B, and C, and they are all natural numbers, so that's it. Okay, so let's look at C then. The cost of insuring a piece of jewellery depends on its value. The table below shows the rates charged per year by one insurance company, where R is real and R is positive. So the first €1,000 of the value of the piece of jewellery is insured at a rate of 1%. After that, the next 9,000 is insured at 2%, and then after that it's R%. Now work out the cost, and you have to add on the previous values as well. Work out the cost per year of insuring a ring valued 1,800. Well, €1,800 can be split up into €1,000 and €800. So the first €1,000 is insured at a rate of 1%. So we need to get 1% of 1,000. So when you do that, you get €10. Then you've got to get 2% of whatever is left. In this case, it's going to be 800. So when you get 2% of 800, you get €16. So the total then is €26. That's our answer there. Okay, so the next one then, the cost of insuring a particular necklace is €142.80 per year. Work out the value of this necklace. Okay, so this is kind of working backwards. So we know that the first €1,000 is 1%. So we've got to get 1% of 1,000, and we saw that that was €10. Now you've got to get 2% of, if we look at the table, 2% of the excess over 1,000 plus the cost of insuring the first 1,000. So that's going to be €9,000. So we've got to get 2% of €9,000. So 2% of €9,000 is €180. So now that gives us a total then of €190. So we've gone over the €142. So the piece of jewelry must be valued at more than 1,000 and less than €9,000. So it's somewhere in between these two. So you got to work that out. Now the insurance is €142.80. So we know it's going to be €10 anyway. So we really just need to look at €132.80. And that is going to be 2%. That's going to be equal to 2% of something. And that's something, let's say, we'll call it X, okay? So they got 2% of that something, and then when they did that, they got €132.80, added the €10 from the 1% of the first 1,000, and that gave them €142.80. So you just got to work out X really. So let's do that. 2% is 2 over 100 times X, and that's equal to 132.80. So you can multiply across by 100, so that'll give you 2X. So that's 13280, and then you just got to divide by 2. So that'll give us, let's see, if you divide that by 2, you get 6640 euros. So that's the amount that the piece of jewelry, the necklace in this case, was valued over €1,000. So the total value then, the total value is going to be the 6640 plus 1,000. That's 7640 euros. And that's it for part 2. A brooch is valued at 17,500. The cost per year of insuring the brooch is €435. Work out or the rate of insurance charged on the amount of the value of the brooch which is in excess of 10,000. Give your answer as a percentage correct to one decimal place. So again, remember we had 1% of 1,000, which is €10. We have 2% of 9,000. 2% of 9,000 was €180. So that's a total of €190. And we can see the insurance here was a lot more than that. It was €435. So they got or percent of a certain amount to give you the difference between these two. So if we take the 435, the total insurance amount, subtract the €190, that'll give you €245. So that's going to be the amount insured in this part of the table here. So they got a certain percentage of something to give you or to give them €245. So the value of the brooch again is €17,500. The first percent and 2%, that's going to represent a value of €10,000. So this €245 is going to be the insurance cost for anything over €10,000. So we're not really interested in the first €10,000. So we've got to subtract that, and that'll give us 7,500. So you want to really know what 245 is as a percentage of 7,500. And when you work that out, you get 3.3%. So that's our OR. So it's just this amount here, the 245, divided by the 7,500 times 100 to convert it into a percentage, and you get 3.3%. That's the value of OR that they're talking about here that we weren't given. Okay, so that's it for this question and this paper.